So the C represents the cost, that one? No, I think that was the same. Oh, okay. Number 6. Let's try that one first. Here. Okay. We're doing a couple problems out of 3.1 and 3.2 before we get started. People have some questions. So on page 181 of 3.1, I'm going to do number 6. And it says if C represents the cost of an item, then the cost is decreased by 7%. The new cost is represented by what? So if C is the cost, the new cost is decreased by 7%. If I say 7%, remember when I told you percents have to be in the form of decimals, and they have to go with something. So what am I taking 7% of? Now, is that my answer, 7% of C? No, it's decreased by that much. So it's the original cost minus 7% of the cost. Does that make sense, Zoe? Yeah. It's just the way they word it, kind of. Okay. Yeah. Okay, whenever you're dealing with percents, typically you're multiplying it by something, you're either adding or subtracting it to the original value. Okay. Sometimes they're just asking for the percent. If they say, what is the tax? Then you just take 7% of that cost. Okay. And Melinda, did you find out from 3.2? Oh, they're not? Oh.
Well, I mean, I can show you the ones I had to do more than once from
which
math
number
lab.
did you have trouble with? 9, you said, or?
Yeah, 9 I had to do twice to get.
All right.
See so, like number 4 I had to do 3 times before I got one right. 7 I had to do twice. 8 I had to do twice.
Okay.
9 twice. So.
I kind of like it because without the actual problem, it doesn't make sense. So it's also, it looks like it's a percent one.
Let's see. I tried to do some of the ones in the book too.
How about 32? Because it says 32 on page 193. Projected to be 4.8% higher in 15 than it was in 8. Would that be one kind of like it?
Wouldn't it?
Okay, let's do 65. 65. This is the last one we're going to do for the quiz, and then if you have more questions, I'd be glad to help you after class. 3.2, page 195, number 65. Let's try that one. Bless you. It says, after Linda Kodama is seated at a restaurant, she realizes she only has $30. From this $30, she must pay a 7% tax, and she wishes to leave 15% tip. What is the maximum price of a meal she can afford to pay? So that's a real life problem. We have $30. She is going to pay a 7% tax, and she'd like to leave a 15%, not tax, tip. Okay, so we need to know what the cost can be of the meal. So let's write the formula. She's going to have the cost for her meal plus what? Plus the tax of 0.7 of that meal. Now this gets a little tricky. When you pay tip, are you paying tip on the price of the meal or the price of the meal with the tax? With the tax. You know when they bring you your bill at the restaurant, it's already got the tax on it? So we have to find this out first, because we need to know what our bill is going to be that comes to the table, right? So this is going to be my total cost. That total cost, I'm going to add a 15% tip. Let's see if I can do it straight. I don't want to make it too complicated. Because that's the most money she has. Very good. She can't go over that. Alright, but I'm getting you into two equations with two unknowns.
Did you try it with the tax too?
Okay. Let's try.
Why wouldn't it be plus 15%?
Well, and maybe this problem's not doing it that way, but if you do plus 15% of the cost, you're only paying a tip of 15% of the price of the meal, not with the tax. Does that make sense?
So wouldn't you put that in parentheses and do plus 15%?
Oh, hold on. She wishes to leave a 15% tip on the price of the meal before tax. They put that in there, so we won't have this problem. Okay. That's not really how it would work in the real world, but they put that little snippet in there where it says she wishes to leave a 15% tip on the price of the meal before tax. So because it said that, I can go ahead and say 15% of the cost of the meal, and it equals 30. Much less complicated, okay? Now, in the real world, if you wanted the 15% on top of it, you would have to have those two equations. But let's just leave it at this. This makes sense to everybody. Okay, we're looking for C. We're looking for how high a price of a meal she can afford. So I'm going to add these together. So it'd be 1.07 plus 0.15. It should be 1.22C. Somebody can check me on that.
Yeah.
Equals 30. What is 30 divided by 1.22? 59? Okay. So that's a nice meal. She can buy $24.59 of a meal and still have enough money to pay for tip and tax. Is that anywhere close to what you were trying to do on that slide? A little bit. We will work a lot more of these problems on review day, I promise. We're going to cover the last two sections today of word problems. And on Thursday, we will have a review. So we're going to work a lot more. Okay, we need to kind of move ahead so I can get the other two things covered. We're going to start by taking a short 10-problem quiz on 3.1 and 3.2. Oh, thank you. Yeah, I don't want to be.
Okay, just for the record, I didn't. So,
I
huh?
need to watch what I lay, huh?
I'm in my own little
Thank you.
stratosphere though.
I didn't know it was trying this new thing.
You're trying honesty?
Just to see how it works.
I always have to be. I'm like the one time I'm not.
I'm like,
like
no.
arrested and
No, just tell her. Oh, I just see her.
We're only going to take 20 minutes for this quiz.
Carolyn or Cherie, are you here? Bless you.
Okay, you can go over these personally. Overview. Was this super hard or okay?
Second one's
I'll
bad.
tell you after I get my grade.
If you're really struggling, you need to make some time to go to that math lab or get some extra help, because the test is gonna be a week from today. And word problems are tough for a lot of people. And the best thing you can do is work lots and lots of problems, not just the homework I assign you in math lab, but just work some out of the book. Just keep working them until you get them. Okay, so the last two sections of this chapter are 3.3 and 3.4. 3.3 is going to be about geometric problems, and it's very short. In your book, you need to open up to page 198 or 197. Okay. Look on page 198, up in the left corner, there's a little yellow box called Understanding Algebra. These are just some geometric facts that you need to know to solve some of these problems. And they're things you should have already learned. You just might need a refresher. Equilateral triangles mean there's 3 equal sides. What do all triangles, angles inside add up to? 180. So all triangles' interior angles add to 180. So if an equilateral triangle has 3 equal sides, each of its angles are 60 because they have to add up to be 180. An isosceles triangle means it has 2 equal sides. Congruent triangles mean that corresponding sides and angles are equal. Similar triangles, corresponding sides are in proportion and corresponding angles are equal. A polygon with n sides is the sum of the measures of the interior angles. Is n minus 2 times 180. What does that mean? That means no matter what polygon you give, it's a pentagon, a hexagon, anything like that, you can figure out what the angle should be equal to by using this formula. Okay, so let's say, for example, a quadrilateral. How many sides does a quadrilateral have? 4. So 4 minus 2 times 180. 2 times 180 is 360. So a quadrilateral's interior angles should equal 360. If it were a pentagon, it would have 5 sides. You put it in the same formula, you get 3 times 180, which is 540. Okay, and so on. So you can figure out the measure of interior angles by using that formula for polygons. Complementary angles. Angles who add up to be 90 and supplementary add up to be 180. Of the ones on here, the ones I would really know are complementary and supplementary, that all interior angles are 180. I don't know if it says that on here exactly. It kind of does with the polygon, because this formula even works for a triangle. Because how many sides does a triangle have? 3. So 3 minus 2 is 1 times 180. Equals 180. So if you just remember this, you can get any polygon shape to know what the interior angle should be. Okay, that being said, let's try some of the problems in here. If you notice, this section is very short. They only gave you 4 examples, and I'm going to do an example like each of them, but I'm going to do the instructor example. So you have one different than what's in your book. Okay. So the first problem we're going to try is about a patio. the length of a patio is to be 4 feet greater than its width. If the perimeter is to be 112 feet, find the patio's dimensions. Okay, pay particular attention to this problem because there is one in the test very similar. So the length of the patio is 4 feet greater than the width. Let's just draw our patio. It helps if you draw pictures to kind of visualize word problems, okay? Their width and length. Based on what we learned last time, what is in terms of the other? What are we basing on the other? What is our unknown?
The width.
The width. I probably didn't say it the right way. That's what I was getting at. The width is our unknown. It's W. Length is based on width, and length is going to be what? 4 feet greater. So it's W plus 4, right? Okay, that was the start. If the perimeter is 112, find the dimensions. Now let's write what a perimeter would be. What is the formula for a perimeter of a rectangle? No, length times width is area. 2 widths plus 2 lengths. We know the perimeter is 112. We don't know W, but what do we substitute L for? W plus 4, because length is the width plus 4. Is everybody with me? Now we can solve for W. We need to distribute. .104 equals 4W. Divide both sides by 4. And I end up with a width of 26 feet. Okay, let's go back and remember when we're doing word problems, we need to make sure we answer the question. It wants to know the patio's dimensions. Can I just say width is 26? I have to say what the length is as well. What is the length? 30. So it's 4, 4. So the answer to my question is a 26 by 30 patio. So the parts of the problem you're going to be graded on. Your unknowns. This is one part. Writing the equation is the second part. Solving, I guess right here would be the third part, and then getting both dimensions would be the fourth part. Okay, so if it's a 4-point problem, those are the 4 things I'm looking for. Looking for, did you know your unknowns? Did you set up the equation, solve the equation, and then answer what it's asking? Any questions on that problem?
I'm confused where it says 2W plus 2 and then W plus 4 because I thought you always make them.
I'm just writing the generic formula for the perimeter of a rectangle. Twice the width plus twice the length. Okay? Then I'm substituting W plus 4 in for the length because that's what length is.
Right, I understood that.
Okay. Thanks for asking. Okay. Next problem is about a triangle. Two larger angles of an isosceles triangle. And what's an isosceles triangle again? Two sides are equal. They're each 30 degrees greater than the smallest. Find the three angles. Okay. Draw ourselves a picture to kind of understand it. Isosceles means two sides of the same. Okay? That one looks kind of equilateral. Maybe I should make it look less equilateral. We'll say these two are the same, isosceles. If the two larger angles of this triangle are 30 degrees greater than the smallest, what are my two unknowns? What don't I know? The smallest angle is my unknown. We'll just call it x. And the larger are what? Good, plus 30. Very good. So in this picture, this would be x plus 30, this would be x plus 30, because it said two larger angles. So there's one small and two large. What did we say about what the total angles have to be? 180. So how am I going to set up this equation?
2 times x plus 30 plus x.
Good. You can say 2 times x plus 30 because there are two of them. Or you could have put x plus 30, x plus 30. Plus x equals 180. Please let me know if I lost you. Okay. That's setting up the equation. We have to add all three angles together to get 180. Now I'm going to solve for my unknown. Okay, so x is 40 degrees. Have I answered the question? No, it wants to know all three angles. So one of them is 40, this one. What are the other two? 70 and 70. So on a test, you would want to put 40, 70, and 70. 70 is repetitive, but it wants to know all three angles. So it wouldn't be enough just to say one's 40 and one's 70. You have to put two 70s. Any questions on that problem? Next problem, got a parallelogram. The two larger angles of a parallelogram are each 20 degrees greater than the two smaller. Find all four angles. Okay, this is very similar to what we just did, except instead of a triangle, we have a parallelogram. How many sides are in a parallelogram? 4. So what do we know about the total measure of the interior angles?
360.
Remember this. Okay, a parallelogram has 4 sides. So we're going to plug 4 in for n. Okay, so 360 is going to be the total of my interior angles. Here's my parallelogram. We have 2 larger angles and 2 smaller angles. If the 2 larger angles are 20 degrees greater than the smaller, we're going to find all 4. So let's say our smaller are x, and our larger is x plus 20. Okay? We have to add all 4 of them up to equal what? 360. So what's my formula going to be? 2x x plus 20 equals 360. Very good. It's very similar to the triangle problem. We just had to know what the interior angles would be. So now that I wrote my equation, let's solve it. I'm starting to skip some steps. I'm not writing minus 40, minus 40. I'm not saying divide by 4. So let me know if I lose you there. Okay, x is 80. So what is the answer to my question, all four angles?
80, 80,
80, 80 are two of them. 100 and 100 are the other two. Very good. Excellent. Okay, one more in this section. And this one, you're going to have to kind of look at that picture on page 199, figure 3.6, to understand what we're doing. I'm going to try to draw it, but it looks better in the book. Okay, this is farmland, and wherever I've drawn a line is a fence. So they're fencing off this acreage and they're putting fence in between. So the problem says, find the length and width if the length is 40 feet greater than the width and 560 feet of fencing is available. Okay, so that's how much you bought at the fence store, where the fence store is. You have 560 feet of fence, and you need to find out what the length and width should be to use that much fencing. Let's figure out what our unknowns are. What's my first unknown? Is width. That is my unknown that length is going to be using in relation to. Because length is 40 feet greater than the width. So that's part one, setting up my unknowns. I'm sorry? 40. Next is to set up my equation. Now we're doing a perimeter problem, but instead of going just around like we would normally do, what other fencing am I going to have to consider? This stuff in the middle. So the total perimeter, total fencing is going to be how many W's? 4 W's. Here, 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 and here. And how many lengths? Lengths. This is length. 2 length. I don't like doing that because it looks like a 1. Okay, great. So that is my formula. Perimeter this time is the total amount of fencing I have, 560 feet. I don't know what W is, but I know length is going to be W plus 40. There's my equation. Now I just have to solve. 560 is 4W plus 2W plus 80. 560 is 6W plus 80. Subtract 80 from both sides and I get 480 equals 6W. Divide both sides by 6 and I get 80 for W. Okay, found W, but I need to find length. So 80 feet of width.
Can you just slow down just
Sure.
like
And 120 feet. Yes, I will stop right here. Get everybody caught up. answered the question to this problem?
Yes.
Yeah. Because it just said what's the length and what's the width gonna be if I have that much fencing.
Wait. You got the width.
She
So
got the
the
length because perimeter is 2W plus 2L. So if 80 times 2 is, let's see, 160, and it's supposed to equal 560, then 120 times 2 plus, 80 times 160.
okay, so but you would have to write out the answer for what is the length and what is the
It
width.
just
You
asks
did
you
do
what
it
is
right,
the
it was
length
just
and
very
what is the
confusing
width.
the way
In my
you did
head,
it.
it's- oh,
It-
okay.
you got it right, it was just.
So it's just wanting to know length and width. And when you're checking yourself, you just want to know I have 4 of these widths and 2 of these lengths. So with that, add up to 560.
But to answer it correctly, it would be 80, 80, 120, 120, correct?
Not particularly in this one, I wouldn't count it wrong, but it's just saying what is the length and the width. It just wants to know how long of a width and how long of a length. It's different than the angle problem where you have to write each one, because it's not asking for each angle, it's just saying what should your length and what should your width be.
Okay.
Does that help at all?
Mhm.
Kind of like if you're sewing or something, you know, you have so many strips, but they only need to be so long. Does that help at all? And this one is in the book as well. So if you want to go back and look at it, it should explain it a little better. Yes.
Why is it 2 equals 4 and equals 2?
Okay, because in this problem, this is fencing. I'm not just doing the perimeter around the farmland. I'm doing fencing in between as well. So there's 4 widths, and there's 2 lengths. No. Because you're going this way 4 times with it.
Oh, I see.
Does that make sense?
Yeah, I know.
Like if you were actually the farmer out there putting up the fence, how many times do you have to bring the fence down? 4 times. And you're having to go this length twice. Does that help? Did you see the picture in the book? Draw it a little better. Okay, how are we on geometric problems before we start the next section? Got the idea. We're using things like interior angles, things we know about triangles, parallelograms. Okay. So 3.4, motion, money, and mixture. Motion is our first M. When we talk about motion, we're talking about rates. Rates like miles per hour, feet per second. Miles per hour, feet per second, and so on. Okay, we're talking about how fast you go. The formula you need to remember from motion is distance equals rate times time. And I think you've probably heard that before. Distance, how far you go, is equal to how fast you're going and how long you went. So if I was saying that I drove 50 miles an hour for 3 hours, how many miles did I go? 150 miles. Okay, that is what we're using in this section. We are going to use charts for all of these problems to help, or tables to help us figure these out. My first example is 2 people start walking at the same time in the same direction. That's important. that they're going in the same direction. One person walks at 4 miles per hour, and the other at 6 miles per hour. And how many hours will they be 0.5 miles apart? Okay. So I've got one person here and one person here. They're leaving at the same time. One is moving at 4 miles per hour. The other is moving at 6 miles per hour. And I'm looking how long will it take for them to be 0.5 miles apart. Because this guy obviously is going faster, right? So he's going to get ahead of him. So I'm looking for how long will it take them to be 0.5 miles apart. That's just kind of a drawing to kind of visualize what you're doing. You don't have to draw that on your paper. I'm just trying to give you a visual. Okay, how we're going to solve these problems is a table. You're going to use the formula I give you for each section and put it at the top. We'll do this in a different color. Rate times time equals your distance. This is going to help you figure this out by doing these tables, okay? This is going to be person 1, and this is person 2. Okay, we got the idea of how to set up the table. We're going to put our formula at the top and the two things we're comparing on the side. So let's fill in what we know. What is the rate of person 1? 4. 4 miles per hour. Person 2, 6 miles per hour. Does it matter which one I put 4 and which one I put 6? It does not. Time. Is that what we're looking for? Do we know time? No, we're looking for it. So that's just our variable. That's t. If distance is rate times time, what is distance? 4t, 6t. Because this times this equals that. Are you with me so far? So I know how far person 2 went and how far person 1 went in some t amount of time, whatever I wanted to put in there. The question it's asking is, in how many hours will they be 0.5 miles apart? If you're looking at this picture, 0.5 miles apart, what are you doing to their two distances to get 0.5? You're subtracting them. You're just taking the one that's ahead and saying this distance minus this distance is 0.5. The distance between them. This is how far person 2 went. This is how far person 1 went. The difference between them needs to be 0.5. Okay? Then we can solve. The hardest part is setting it up. Once you get to this point, you're just solving. So 2t equals 0.5. So t equals 1 hour. Okay, why do I know it's hours?
Because you don't know how many hours it will take.
Well, and because the rate is in miles per hour, I know that my time has to be hour. Okay? So t is 1 hour. In 1 hour, they will be that far apart. That's one kind of motion problem. Let's look at the other kind. In this one, they're going the same direction. And the next one, they're going to be going opposite. Do you see it okay, Shannon?
Yeah, I'm just not following the math.
How that comes to hours. I got 4.25.
Yeah, I got 0.25 as well.
0.5 times 2?
No, you
Divided by.
you have 2t equals 0.5, so wouldn't it be 0.5 divided by 2 and I got 0.25,
Yeah.
yeah, so how does t equal 1 hour?
I multiplied, so divided.
Ah,
So, my bad.
okay, so,
So it's a fourth of an hour, 0.25 hours.
You would take either one, 1/4 of an hour or 0.25
Yep, or
hours?
you could write a fourth of an hour, or you could write, what's a fourth of an hour, how many minutes?
15 minutes.
15 minutes, but because it's in hours, leave it in hours. Yeah, I don't know why I multiplied, I apologize. I need to change that in my notes.
I thought I did something wrong.
No.
I already explained something wrong before I went there.
Yeah, and even in the book. I just got carried away. Okay, 125. Very good. And there's an example like it in example 1 on page 203. Similar problem on a camping trip. Okay, the next kind of problem is going to be like example 2. Here they're going to be moving towards each other actually. So they're in different directions. So you're looking if they're going in the same direction or opposite directions. Zoom on this one. Catch up. And then you do it. First I want to draw a picture. It helps me anyway. Sometimes it helps visualize it. I've got a runner over here and a runner over here. How far apart are they? 6 miles apart. They're running towards each other, okay? And they're going to meet after 0.4 hours. So in this problem, what are we looking for? Their speed, their rate. So let's draw our table. Ready? Rate times time equals distance. We got person 1 and person 2. Rate is what we're looking for this time. However, it did tell us a little bit something about the rate. What did it say?
One is going 0.5 miles per hour faster than the other.
Good. One is 0.5 faster than the other. So if one is just R, what is the other?
R plus.
Good. Okay. That's kind of some of the stuff we did last time, right? How we put one thing in terms of the other. One is whatever rate, the other one's going to be 0.5 more than that. Do I have time in this problem?
Yes.
It's gonna be 0.4. Do I have enough information to write the distance for each? Yes, because this is multiplication. So the distance here is 0.4 r. This one is 0.4 times r plus 0.5. It's important to put that in parentheses because you do have to distribute between both. Very good. So we filled in our table. Now what can we say about their distance? The distance this dude runs and this dude runs, their total running distance is going to be what? 6. It doesn't matter if he went 4 and he went 2, it's going to be 6. Their total can only be 6. So what am I going to do with these two distances?
Make them equal.
Not equal, make them equal to 6. I'm going to add them. I'm going to say whatever person 1 ran distance plus what person 2 ran in distance is going to be equal to 6 miles per hour. So this is the important part of the problem, is setting that up. So you have to understand it. Now I'm going to solve the problem. Stop for a second and catch up. Now the rate is 7.25. That's the rate of who?
The slower one.
The slower one. Person 1 is slower. And the rate of the faster one would be 0.5 more than that. So 7.75. What did my question ask? Find the speed each person is jogging. So I have to write both. I have to put 7.25 is 7.75 miles per hour. Don't forget your units. And don't forget to go back and make sure you answered the question correctly. Okay. The real important thing I want you to know about motion problems is this. You need to remember the formula. Distance is rate times time. And I want you to know if they're moving in the same direction, it will involve subtracting. If they're moving in opposite directions, it will involve adding. That's important, okay? And you can see that in these two problems. These are moving in the same direction, so we ended up having to subtract. Those were moving in opposite directions, and we had to add. All right, that's motion problems. Any questions? Most times. Next is money, money, money. And just like motion, there's going to be one formula I want you to know that you're going to use to set up a table. And for money problems, the formula to remember is I equals PRT, or PERT. I stands for the interest. P is the principal. R is rate. It's a different rate than we just talked about in motion problems. Rate here is going to be a percent that gets turned into a decimal. And finally, I have time. Time is in terms of a year. Okay, year or years. So the rate is not like what we just did. It's a percent, but we're going to turn into a decimal, and time is always in 20 years. Okay, that being said, let's try it. How should $12,000 be invested for 1 year? Part at 7% simple interest. And part at 5%. Simple interest is different than compound interest. It's just the percent over a year. If the total interest is to be $740. Okay, we're going to invest $12,000. We know we're going to end up with $740 in interest at the end. How much money did I put into each account? So before I start drawing the table, I want you to remember what we talked about with totals. If I give this much to this account, how much am I going to put in the other account? 12,000 minus X. Very good. That goes back to what we did in the earlier sections. Okay, now we're going to draw a table just like we did with motion problems. And here I'm going to have principal times rate times time equals interest. Okay, that's what my table's going to look like this time. I'm using the formula and I'm writing it across the top. I'm comparing two things. I'm comparing the account 1 and account 2. Let's look at principal first. I kind of did it for you over here. If I put a certain amount in account 1, how much am I putting in account 2? 12,000 minus X. Because that's all we have for money to invest. So whatever I put in 1, I'm putting the difference in the other. Okay? Rate. Account 1 is going to be 7%, but how do I rate that? 0.07. Very good. Percentages have to be written as decimals. And this one will be at 5%. What is my time in this problem?
1 year.
1 year. Okay, I have enough in the table to find my interest. This is 0.07x, and this is 0.05 times 12,000 minus x. So I'm just multiplying the 3 together this time.
How do you put the quote 7 on top of
Doesn't matter. No. Just one is one account at this rate, and the other is at the other. That's a good question. It should still come out the same. Okay, I know what the interest in each of these accounts will be. What do they have to equal? 740. So I'm going to say account 1's interest plus account 2's interest has to be equal to $740. This is the key right here to this part. Now I go about solving. So 0.07x plus 0.05 times 12,000 is 600 minus 0.05x equals 740. Combine like terms and I get 0.02x plus 600 equals 740. I know it's getting hard to see. Let me know if you can't. 140. So when I divide both sides by 0.02, x will be 7,000. Give you a second to catch up on that, then we'll talk about the answer. If X is 7,000, what does that answer from?
It's 7,000.
Did you put like, do something with this 0.07 right now?
It's just this, it's just how much I am gonna put in, that account one.
Account 1 is 7,000.
So account two, I'm putting how much? 5,000. Our 7,000 and 5,000 equal 12. Yes. So your answer would be, I'm going to put 7,000 in, I'll remember here. 7,000 at 7%. Is that what you meant when you said that?
Yeah.
At 5%. Because you do have to distinguish which one you're putting in at which rate. You see all that over there, Sharon? We're pretty far away.
I'm just trying to write everything
Sure.
down.
I'm trying to slow down. Okay, here's the next money problem. 12 paintings were sold for a total of $400. Some were sold at $20 each. While others were sold at $52 each. How many paintings were sold at each price? Okay. We're going to use the table again, but this time we're not doing interest, so we're not going to use that formula. What we're really comparing is what? What are we comparing? How many at each price, right? So how many different options are there?
2.
2. We have paintings sold at 20 and paintings sold at 52. That's what we're really comparing. We're saying there were a number, how many paintings, the number of paintings times their price is the total amount we made, right? So this isn't a formula really to memorize, you're just thinking this through. You're thinking, I'm taking however many at a price for it to equal something. So I'm looking for a certain number of paintings sold at $20. How many paintings were sold at 52?
So it's really 12 minus.
12 minus X. We're looking for one of those total things. Total minus the first. So if I sold X amount at 20, I sold 12 minus X at 52. That's what we're looking for, is the quantity of each. These sold at $20, these sold at $52. So this is 20X, and this is 52 12 minus X, because I'm just multiplying these two things together. So if I add up all the money made, 20 times however many there were, and $52 times how many there were, what should it equal? 400, a total of $400. Okay, so this is unit and price. kind of problem. You're saying how many at this price, how many at this price should be my total. Now I can go about solving. X equals 7. So my answer is I have 7 at $20, and how many at 52? 5 at 52. If you don't like the table in this problem, another way to maybe think about it is this. I have 12 total paintings worth $400, and I'm splitting them into $20 a painting and $52 a painting. So however many is here is 12 minus that many here. It's just a different visual way to look at it. It's the same thing as the table, but sometimes I prefer to do the tree. Does that make sense at all? Does that help at all? Okay. So you're really saying this plus this has to be this. And behind x plus 52 times 12 minus x has to be 400. That's just a different way to look at it. All right, that's it for money problems. The last one is mixture. So motion, money, and mixture. This may be the most challenging chapter of the course for some people. You just need to spend a lot of time working the problems. It will click at some point. The light will go off. But you're not going to be able to just do 1 or 2 problems. You're going to have to work several to get this down. Okay, the last kind of problems we're talking about are called mixture. And these problems are where 2 or more quantities are combined to produce a single quantity. We can mix solids, or we can mix liquids. An example of mixing solids would be bushels of corn. Like if you pick yellow corn and white corn, and you mix them together, okay? I'm trying to think of something else. Gravel. I've got white gravel and red gravel, and I'm mixing them together. That's mixing solids. Mixing liquids, there's lots of examples. Mixing paint, mixing chemicals, mixing clean fluids at home with water to condense it, that kind of thing, okay? When we're mixing solids, this is the formula I want you to know. Quantity times price is the value. Okay? So you're saying like 3 pounds of gravel at $2 a pound is this value. Make sense? Liquids. What I want you to know with that one is
that Q plus 1
quantity, I'm sorry, quantity. I'll spell it out. Quantity times price is value. Liquids, quantity times its strength is the amount. Okay? So if I'm putting in hydrochloric acid that's 5% and water that's 0%, I mix them together, and what is my concentration? And this will make more sense when we do the problems. But these are the 2 things I want you to remember for your tables at the top. let's try a solid problem first. £3 of type A sunflower seed sells for $3.60 a pound. And it's mixed with 2 pounds of type B seed, selling for $4.80 a pound. A little pricier seed. What should be the cost per pound of the mixture? These kind of problems have lots of real world like applications. I can think of a lot of places you need to know this kind of information. Okay, let's do our table, just like we did before. And at the top, we're going to use which formula? The solid or the liquid?
So,
The solid. So at the top, I'm going to have the quantity times the price equals the value. Boom. Boom. Here, I'm going to have 3 things because I've got one type of seed mixing with another seed to give me a mixture. So I'm going to have the first seed. Actually, they call these A and B, so we'll do that. Type A, type B, and the mixture. Okay. What is the quantity for A? I think I heard it. 3? Can I say 3? Yes. 3 pounds. What is my quantity for B? 2. So what is my mixture going to have? 5. Very good. That part was easy. What is my price for A? My price for B was $4.80. The price for the mixture is what we're looking for. We don't know. The value is just going to be quantity times price. So 3 times 360, which is 10.8. 2 times 4.80, which is $9.60. And the value of the mixture is going to be 5x. So how do you think I set up the equation?
wait, how did you figure out it was 5x? I'm sorry.
Quantity times price.
Oh, okay.
Because it makes sense that A plus B equals mixture. Then we're going to say A's value plus B's value is going to be the mixture's value. So let me come over here and say 1080 plus 960 equals 5x. All I'm doing is saying the value of A plus the value of B is the value of the mixture. When I add these together, I get 20.4 equals 5x. Divide both sides by 5. And I get 4.08 for x. And it's $4.08 per pound, right? Because we're looking for the same kind of pricing, dollar per pound. So I should charge $4.08 for the new mixture. So it seems like a hard problem, but the U table helps. I think. Any questions with this one before I move on to a liquid?
So we would write it like 408 over pounds?
Yes. Dollars per pound. All right. Let's try a liquid problem. So with money, mixture, and motion. If you can remember those formulas at the top, it's really going to help you figure them out with the tables. Okay. How many liters of an 8% sulfuric acid must be mixed with 6 liters of a 15% solution to get a solution that is 12% sulfuric acid. Those of you who have taken chemistry, you're going to do this kind of stuff a lot. All right, let's draw our table. Again, I'm comparing 3 things. What is my formula going to be at the top? Quantity times strength equals the amount. Very good. Quantity, strength, amount. I have 1 solution, 2 solutions, and a mixture. I'm so sorry. Alright, so let's start filling it in. My first solution, how much of it do I have? Do I know?
We have enough to know.
No, that's what we're looking for. What is the strength of the first one? 8%. How should I write that? Very good. The second solution, we know how many liters, right? 6. At a 0.15 solution strength. What is the quantity of the mixture? X plus 6 or 6 plus X. Do we know the strength of the mixture? We want 12%, right? We want the mixture to be 12%. I've got all my boxes filled in that I can do my equal amount. To find my amounts, I'm simply multiplying. So I have 0.08x, 0.15 times 6, which is 0.9, and then I have 0.12x plus 6. Stop for a minute, let everybody catch up. Ask me any questions about the table.
Is it 0.12 times 6 plus 6?
Times x plus 6.
Yeah,
because you're doing this times
Times
this.
that. Okay.
Okay, so how do I set up my equation? We're working with this final column. When we're doing these tables, we're looking at this final column to set up our equation.
It would be 0.9 plus 0.12 times x plus 6 equals 0.08x.
No, you're still mixing. Let's visualize this. I've got
So you
this
said it
much.
equal to 1 and 2 added together is equal
Correct.
to the mix.
I've got, we don't know how much of this, this one's 8%, this one's 15%. I'm just giving you a visual. We're pouring it in 1 vat. Give me x plus 6, 12% solution, okay? So I'm adding these 2 amounts to come to my mixture. So I have 0.08x plus 0.9 equals 0.12x plus 6. I'm using this final column to set up my equation. 1 solution plus the second solution gives me the third solution. Alright, any questions with that part? When I go through solving, let's see what I get. 4.5 what? What is X? Liters. Okay, let's go back and make sure we've answered it. How many liters of 8% is needed? Is X my answer? It is, yeah. This time it doesn't want how many quantities in the solution that we're making. It wanted to know how many liters of this acid was needed to make this. So my answer was just 4.5 liters is how much I'm going to need. Okay. An additional question could be, how much will be in the total solution? And then you just say 4.5 plus 6. But in this particular problem, I just wanted to know how much of the 8%.
So is the quantity what's in liters then?
The quantity is in liters, yes. Because here, 6 liters tells me that's how much it is of the other. Okay. I have 2 more mixture problems. We'll leave that up there. You guys are quiet, either you're bored or confused or
Overwhelmed?
tired or what?
Overwhelmed.
Overwhelmed. Okay. Please ask questions along the way if you get lost.
Well, I guess my question is there an easy way to remember which table to set up?
The key is to remember these formulas that I'm writing down here for each kind of problem. You can remember those. Remember, mixture is this equation. Liquids is this equation. And I gave you one for money, and I gave you one for motion. There's only 4. So if you can memorize those equations, that will help you set up the table. How much of a 16% and a 30% iodine solution must be mixed to get 20 ounces of 25% sodium iodine? And don't let these big words scare you, the sodium iodine and the sodium chloride. Really, you're just looking for what you need in that table. You're looking for strength, you're looking for quantity. Don't read it and be like, oh my gosh, I don't know what sodium iodine is. That doesn't matter. All we're going to do is draw our table and fill in what we know. Okay, so is this a solid problem or a liquid problem? Liquid. So what's my cup going to look like?
Quantity times strength equals
Good. Quantity times strength equals an amount. You notice they're very similar equations. They're doing the same thing. It's just in solids you're doing a price per pound, and with liquids you're doing the strength of the solution. They're really the same formula. Okay, what am I comparing in this one?
Solutions for
So can I just write 1, 2 and mix again, you think? Does that work? Sure.
yeah.
Does it matter which one I choose to be mixture 1 or mixture 2? No. Okay, let's fill in what we know for the first one. What's the first solution I have? What is its quantity? Do we know?
We don't know.
We do not know. But do we know the total amount that we're going to have? What is it? 20. So what should this quantity be? 20 minus X. This is one of those total things that we've done. So if I know the total's 20, I know whatever goes in this one's going to be 20 minus that. That's the first column. Strength. We'll say this one is 16%, this one's 30%, and the mixture is 25%. All that was given to us. The amount, we just multiply straight across. So I get 0.16x, 0.3 times 20 minus x, and 0.25 times 20. So really the hardest part of setting up this table is understanding this, equal 20 minus x. How to solve my problem? What do I need to do with my last column? Add one solution to the other solution, I get my mixture. So it's just 0.16x plus 20 minus x equals 0.25 times 20, which is 5. 0.16x plus 6 minus 0.3x equals 5. 1 equals 0.14x. Therefore, x is 7.14. Don't let this part really bog you down right now. We already know how to solve equations. This is not the important part of today. The important part of today is figuring out how to fill in the table and how to set up an equation. I don't want you worrying about this as much. Okay, that's why I'm doing it kind of fast. Once you get your answer, however, what is that telling you? What is x? The quantity of the first solution. What kind of units should it be in? Ounces. What is my question asking? How much of the 16% and 30% must be mixed? So this can't be my only answer. 7.14 is at 16% solution. So 20 minus that, 20 minus 7.14, should be the quantity of the second solution. What is it?
12.86.
20 minus 7.14, 12.86 ounces at the 30% of solution. Okay? So this particular question wanted to know how much of each. That would be your answer. 7.14 at the 16%, 12.86 at the 30%. Okay, one more problem to go. I'm not even gonna redraw this table. I'm just gonna do this. Last problem for today. The solution of 4 gallons of salt water is 3% salt. If 5 gallons of tap water is added to the salt water, determine the percent of salt in the mixture. Okay, so let's look at solution 1. What is the quantity? 4 gallons. What is the strength of 1? 0.03. Very good. What is the quantity of 2? 5 gallons. Now here's kind of the tricky part. What's the strength of water? 0. Wasn't that tricky? You guys are smart. And the mixture is going to be how much? 9. We don't know the strength. That's what we're looking for. Okay? So we've got that all set up. Now we go straight across. 4 times 0.03 is 0.12. What's 5 times 0? 0. And 9 times x is 9x. So to set it up, we say 0.12 plus 0 is 9x. So really all this water's doing is watering it down, right? Watering it down. So 0.12 equals 9x. If I divide both sides by 9, x is going to be 0.0133. Now here's the first one we've done like this. It's asking for strength. I got this for x. What way did they give me strength in the problem? In a percent. So should I put this back in a percent? I should. By moving it twice to the right. So it's 1.33% strength. Okay, so that is tricky. We haven't had one like that where we were looking for strength. When you get your answer, put it back into the percent. So it matches what was given. Alright guys, I know it was overwhelming today. Please, please, please do your homework. Work some problems in your book. Go to the math lab. You've got to practice on this. On Thursday, we're going to review everything. We're going to do lots of problems, and we're going to help you. And we're going to review for this test. But you've got to do some work outside of class. Okay? Have a good day.